Good afternoon, everyone. My name is Ade, as you all know. So, welcome to another episode with Learn with Intesa. But today we'll be going through elasticity. So, and what these are the four things we are going to be looking at today. We are going to be looking at elasticity. We're going to be looking at stress. We look at strain and Hooke's law. So, join me as we ride on together. So, let's look at elasticity. I know many of us will have been hearing the word elasticity. What does it mean? Yes, is what you are thinking, elastic. Now let's define elasticity. Say elasticity, we define elasticity as the ability for an object to regain its original shape after being stretched or compressed. Remember the word stretch or compressed. Those things cannot just happen to an object except an external force is being added to it. So any object that can regain its original shape or form or volume after you add external force to it, that object is said to be an elastic object or an elastic material. So after we've talked about elasticity, let's talk about stress. Stress is the internal force per unit area of a material when an external force is being added up to it. Now, you say you are, if let's say you are stressed, that means you must have done some work that now bring an internal force into your system. That's what we call stress. So now, stress has a formula. Mathematically, we say stress is equals to force over area. And the units for stress is, we all know the unit of force can be Newton and divided by meter square, because the unit of area is meter square. So now, with this, you can solve any question coming under stress. Now, we define strain as a change from the length, the change of the extended length to the original length. Let's say you have a rubber band at this level. Now you stretch it, that is, you added an external force and it moved to this level. Now, this is the initial length, and this is the new extended length. Now, strain mathematically is equal to the extended length divided by the original length, which can we say, we can call it E over L. Now remember, strain has no units because the extended length is still measured in meters and the original length is also measured in meters. So we can see that this has no units. So we can also say strain has no unit, but stress has a unit of Newton per meter square. So Hooke's law states that the force on an elastic material is directly proportional to the extension of the material. Now, provided the elastic limit is not exceeded. Okay, and mathematically, Hooke's law is stated as F is directly proportional to A, which is the extension. Now, we all know we can't leave it this way. So we have to introduce something called K. And now we can now say F equals to KE, where our F remain the force, E is the extension, while K is the elastic constant. K is the elastic constant. And now, after we've explained these four concepts under elasticity, we'll now go to solving questions that can come under each of these three concepts. Now, a question under stress. The question says, I hang a 10 Newton weight. And you can see 10 Newton weight, that's our F, is 10 Newton from the question. And our area is 2 centimeter. Now we are told to find the stress. Now, first of all, we already have our force, which is in Newton, and we have our area, centimeter square. But you can see we are not using centimeter. We are supposed to be using meter. So now we have to convert our centimeter square to meter square. You can now see 2 divided by 100 times 100, which is the same thing as 2 over 10,000. And in the standard form, we can now say 2 multiplied by 10 raised to the power minus 4 meter square. And now this is balance. Now we can now look for our stress. We can now say the stress on that material is equals to our force, which is 10 Newton divided by 2 times 10 raised to the power minus 4. And now with standard form, you can say 1 times 10 raised to the power of 1 divided by 2 times 10 raised to the power minus 4. And now we can now say 1 over 2, which is 0.5 times 10 raised to the power 1 minus 4. And now 0.5 times 10 raised to the power of 1 minus 4, which is still 1 plus 4. 1 plus 4, and which is 5. So which make our final answer to now be 5 times 10 raised to the power of 4 Newton per meter square. And this is the solution for this question. Question is we'll be solving using the formula to Hooke's law. And the formula, remember, is F equals to K multiplied by the extension. And remember, the K is a constant, is a force constant. Now, this question is telling us that our F is of 15 Newton. But remember, he now said the material has an initial length of, let's call it our L1, 7 meter. And after the force was added to it, it moves to L2, which is what? 11 meter. Now we are told to find the force constant, K, which is unknown. Now you see, we are not given E, but we can derive our E from what is given to us by saying L2 minus L1 is our E. And what's our L2, which is 11 meter minus 7 meter. So our E is equal to 11 minus 7, which is 4 meter. So our extension E is 4 meters. Now, remember F equals to KE. And now we need to make K the subject of the formula because we are looking for K. Now we do what? We divide both sides by E, divide here by E, and divide here by E. Then our K will now stand independent, equals to F over E, which is the extension. Now K finally will now be 15 Newton divided by 4. So K will now equals 3.75. Cut. So Hooke's law gave us another important relationship because Hooke's law states that aside from force and extension, it also states that stress is directly proportional to strain, and which leads us to ST. Okay, STS is directly proportional to STN. And you can see this mathematically, we can now say STS, which is our stress, is equal to E multiplied by STN. And E is a constant that we introduce in to balance this. And E can now equals STS, which is our stress, divided by STN, which is our strain. And this E is what we call modulus. E is called modulus. Can be modulus of length or for volume. So this so modulus of length, modulus of volume. And now with this, we've come to the end of this session. And remember, we've treated elasticity, we talk about stress, we talk about strain, Hooke's law, which leads to the relationship between force and extension, and also relationship between stress and strain. And we solve some simple questions, which I believe you should be able to understand and solve more of those questions. Practice it on your own. So with this, I'll be seeing you in the next session. Thank you so much. I'm Hadi.